Assalamualaikum warahmatullahi wabarakatuh. Hello and welcome to today's tutorials. I'm excited to show you how to create a simple AWS Lambda function using Java. We'll be leveraging Terraform for resource provisioning to automate the setup process efficiently and ensure that our infrastructure is managed as a code. This approach not only streamlines deployment but also ensures consistency and scalability in your cloud environment. Let's dive in and get started with creating our Lambda function using Java and Terraform. I will show you my folder structure. My Java source code is at here. src main java com example, and this is my source code, my lambda function.java. Let's start with package at the top. This line declares the package name com.example, which is a way to organize related classes and interfaces in Java. It helps in maintaining a clean and modular code structure. Next, we import the necessary classes from AWS Lambda Runtime Library. These two lines. The context interface provides runtime information about the Lambda function invocation, such as AWS request ID, log stream name, and other metadata. The request handler interface defines a standard method for handling Lambda function requests. Now let's dive in to the main class declaration. Public class my lambda function implements request handler object and string. Here we define a public class named my lambda function that implements the request handler interface. This interface requires us to implement a method called handle request, which will be invoked by the AWS Lambda service when the function is triggered. The request handler interface is parameterized with two types: the input type object in this case and the output type string in this case. So let's look at the handle request method. This one. The handle request method takes two parameters. First one is object as an input. This parameter represents the input to the lambda function. It can be any type, but here we are using generic object type for simplicity. The second one is context. This parameter provides runtime information and allows us to interact with the lambda function execution environment. Within the handle request method, we log the input received by the lambda function. This one, context.getLogger.log. Using context.getLogger.log, we can log message to Amazon CloudWatch logs, which is useful for debugging and monitoring the function's behavior. Finally, we return a simple string message, hello from Lambda. This string will be output of our Lambda function, which gets returned to the caller. To summarize, this Java code defines a basic AWS Lambda function that logs the input and returns a greeting message. It is a great starting point for understanding how to build and deploy Lambda functions using Java. And then the next step is we need to build the Lambda function. I have set up underscore gradle.sh in here, and you need to run this script. Before you run this script, make sure that Gradle is installed in your computer. So let's try it out. Okay, the build is successful. So we need to see whether the zip is in there or not. So the zip is located in the distributions in the build folder, this distribution, and this is the file that we need to upload to AWS as one package of Lambda function. As I said to you earlier, I'm using Terraform. So the first one is I want to talk about this providers.tf. This is a simple providers because I'm in Jakarta region, so I fill this AP Southeast 3. And the second one is im.tf. In this block, we are creating an IAM role named Lambda role. Let's break down the key elements. Name Lambda role. This specifies the name of the IAM role. And this one, assume role policy. This is a JSON policy that defines who or what can assume this role. The assume role policy uses the JSON code function, this one, to convert a JSON object into a JSON string. Here's what inside. Version. This indicates the version of the policy language. Then the statement, this one. This array contains one statement that grants permission to assume the role. And then the action, sts assume role. This specifies that the action allowed is sts assume role. The effect is allow the specified action, and the sid, this statement id, this is an optional identifier for the statement, and the principal, this defines who can assume the role. Here it specifies that the principal is the Lambda service, lambda.amazonaws.com. Next, we attach the policy into the IAM role to grant it the necessary permission for Lambda execution. In this block, we are attaching AWS Lambda basic execution role policy to our Lambda role. So let's break it down. The role, this AWS underscore IAM underscore role dot lambda underscore role dot name, this specifies the IAM role to which the policy will be attached. We are using the name of the role created earlier, and then this one, the policy ARN, this is the Amazon resource name of the managed policy we are attaching. The AWS basic execution role policy grants only the basic permissions that are required for a Lambda function to write logs to the CloudWatch. To summarize, these Terraform resources define an IAM role with an assume role policy allowing Lambda function to assume it, and attach a policy providing the necessary execution permissions. This setup is crucial for ensuring that our Lambda function has the appropriate permissions to operate securely and efficiently. So now let's open lambda.tf. In this block, we are creating an AWS Lambda function with the following key element. So the function name, this specifies the name of the Lambda function. Role, this assigns the IAM role to the Lambda function, ensuring it has the necessary permissions to execute. Handler, this is one of the key things. This defines the fully qualified method name that AWS Lambda calls to start an execution. It is in the format package.classname : method name. So remember this address. Runtime, this specifies the runtime environment for the Lambda function, in this case Java 11. Timeout, this set the maximum time in seconds that the function can run before timing out. Memory size 128, this specifies the amount of memory in megabyte allocated to the function. Next, we provide the deployment package and its source code hash. File name, this specifies the path to the deployment package zip file. This one, this in the folder distributions. Source code hash, this ensures that the integrity of the deployment package by the providing a hash of the file. If the file changes, Terraform will detect it and then update the function accordingly. Wow, I think this is the cool feature. We also define environment variables for the lambda function. This is just for the example, but in the real production you would like to fill this with your own case. This block sets environment variables that the lambda function can access during execution. In this example, we have a single key value pair. Finally, we define an output to capture the lambda function name. This block provides the name of the lambda function as an output, which is useful for referencing it in other Terraform configuration for informational purposes. To summarize all of it, this Terraform configurations defines a complete AWS Lambda function setup, including the function name, IAM role, handler, runtime, deployment package, and environment variables. By using Terraform, we ensure that our infrastructure is managed as a code, providing consistency, scalability, and ease of maintenance. Okay, now so let's try it out. Open the terminal. So I scroll it up. Type Terraform init and Terraform apply auto approve for the sake of demonstration. Hit enter. Okay, it is now creating the lambda function. Okay, apply completed, resources 3 added, 0 changed, and 0 destroyed. So let's navigate to AWS management console. So this is my AWS account in the lambda page. So I hit refresh, and then alhamdulillah, this is our function. So click this, and then you will see that our lambda function is properly set up. But wait a minute, we need to test this lambda function to know whether this code is working or not. If you click on the code source, you will get notification that the code editor does not support the Java 11 runtime. So this is good. Then click test. Then to test the function, let's give it a name, example, and then I'm okay with this. Now click save. Okay, test event sample was successfully saved, and then click test. Executing, and now alhamdulillah our lambda function is properly set up, and then here you go, you got hello from lambda. So let's take a look at the screen. Looking at the screen, we can see that the lambda function execution succeeded, indicated by the green success message at the top. The test event named example was successfully saved and executed. In the main part of the screen, we have several key sections. So let's check it out. This one, log output, we can see that the log output hello from lambda, which confirms that our lambda function executed the handle request method and returned the expected output. In the summary, for this one, code SHH 256, this is the hash code of the deployment package, ensuring the integrity of the code being executed. The hash value is unique to this deployment. This one, request ID, this is a unique identifier for this specific lambda execution, useful for tracking and debugging. Init duration, this one is the initialization duration was 393.55 milliseconds, which is the time taken to initialize the lambda function environment. Build duration, the build duration is 355 milliseconds, which is the actual time AWS builds you for these executions. Max memory use is 82 megabyte of memory out of the allocated 128 megabyte, indicating the efficient resource usage. So let's navigate to this part. Execution time. The execution timestamp is here, providing a timestamp for when this function was run. Function version is always to dollar underscore dollar latest. This means that indicating that this is the most recent deployment of our Lambda function. Duration. This is the total execution duration and was 353.54 milliseconds, showing how long the function took to run from start to finish. Resource configured. This is the Lambda function configured with 128 megabyte of memory, which is an important parameter for managing function performance and cost. Then let's navigate to the log output session. These log output sections provide detailed logging information for this execution. It starts with start log entry showing the request ID and some input parameters. The report entry summarizes the execution, including the duration, build duration, and memory usage. These detailed execution metrics are critical for monitoring and optimizing the performance of your Lambda functions. By analyzing these metrics, you can make informed decisions about adjusting your memory allocations, optimizing code, and managing costs. In conclusion, this execution summary provides a comprehensive view of Lambda function performance, ensuring that it runs efficiently and effectively in your AWS environment. So that's it for the tutorial, but before I leave you, let's destroy all of the resources that we are created. So just type terraform destroy auto approve and hit enter. Okay, now it is currently refreshing state and deleting all of the resources, the IAM policy, the Lambda function that we were just created. Okay, Alhamdulillah, destroy complete, resources 3 destroyed. So that's it, everyone. Thank you for watching. Don't forget to likes, comments, and subscribe. Wassalamualaikum warahmatullahi wabarakatuh.